Hi, folks. We are going to solve systems of equations today. There's a few different methods for solving systems. Today, we're going to focus on the one that is traditionally taught first. We're going to solve them by graphing. For this to work, you need to be familiar with how to graph a line using an equation in slope intercept form. So y equals mx plus b. If that's not something that you're comfortable with, I would recommend stopping this video and going back and watching that video. I'm not going to reteach that. You'll see me using it, but if it's not something that you feel comfortable with, you should probably do a review on that first, okay? Okay. So a system of equations is two equations that are happening at the same time. So when we're graphing them, we're going to put them on the same coordinate plane. Their solution is where they're equal at the same point at the same time. It's where they cross. Okay? So for my first equation here, y equals x minus 1. My slope is the coefficient of x, so that would be a 1. My y-intercept is the other number, so that's a -1. So to graph that, the first thing I'm going to do is put my y-intercept on here. So -1, there's my point. Now from there, my slope is a +1. I'm going to turn that into a fraction. Just put a 1 on the bottom. Positive tells me up and right. So when I teach how to graph with slope intercept, usually I have you do one new point. So from this one we just made, up 1, right 1. And then I tell you to graph your line, draw your line that goes through the points, past the points, arrows on both ends. For systems, I actually don't draw the line. I'm going to continue stair-stepping up and over. So up 1, right 1, up 1, right 1. I'm going to do that until I can't fit it on my coordinate plane anymore. And there's no guarantee that when they cross that they're going to cross in that first quadrant in the top right. So I'm also going to extend it in the opposite direction. So instead of going up and right, I'm going to go down and left. So from that first point, I'm going to go down 1, left 1, down 1, left 1. So it's my line. It's just looking at every single point. Okay. It's helpful to do these in two different colors. So if you have colored pencils or different colored pens or something, that might come in handy. If not, it's totally fine. But I am definitely going to use a different color so that you can see this a bit better. So my second equation, my slope is a 2. I'm going to make that 2 over 1, and that means up and right because it's positive. My y-intercept is at a -2. So I'm going to come down here to a -2 on the y-axis. You know what I just realized I did? When I was talking about the y-intercept on the first one, I wrote y equals. It's not y equals. Y-intercept is a b. I know, I'm sure you were going to lose sleep over that if I didn't fix it, but once I realized it, it was bugging me. Okay, so my y-intercept on the second equation is -2. So my starting point is -2 on the y-axis. From there, I'm going to go up to right 1. Hey, we don't have to continue. I've already found where these two lines are going to intersect. If I did go in and draw my line, so that first line, the red line, looks like this. If I draw my second line, what you're going to find is that they cross at this point. So the solution is the point. Let's see, that would be 1, 0. What that means is when x is 1 and y is 0, that point works in both equations. If you plug it in, this would say 0 equals 1 minus 1, and that's true. This one would say 0 equals 2 times 1 minus 2, and that's true. Because that x and y combination works in both equations, that's the solution to my system. Visually, that's the point where they cross on the coordinate plane. Let's do some more. Okay, first equation here, y equals 4x. So my slope is the coefficient of x, that's a 4. I'm going to make it a fraction by putting a 1 on the bottom. Positive means it's telling me up and right. My y-intercept, it doesn't say plus or minus anything, so that means it goes through the origin. It goes through 0, 0. So my starting point is going at 0. From there, I'm going to count up 1, 2, 3, 4, and over 1. I could do it again. I know it's going to go off the coordinate plane a little bit, but that's okay. 1, 2, 3, 4, over 1. If it ends up crossing down in the bottom left, I could go down 1, 2, 3, 4, over 1, down 1, 2, 3, 4, over 1. I'm not going to connect them right now. I'm going to see if one of those points is where they cross. Now, it is possible sometimes that they don't cross at whole numbers, that they would cross at a fraction. When that happens, it's actually better to use one of the other solution methods for your system, just because on your graph, it's hard to tell, is that exactly at a half? Is it at a fourth? Is it something messy like, 5/7, 5/8? But when they're whole numbers, then this graphing method works pretty well. Okay, my second one, my slope is a 1. That's a 1 over 1, and it's positive, so it means up and right. My y-intercept is at a 3. So my starting point goes at 3 on the y-axis. From there, I'm going to go up 1, right 1. Hey, look at that. That's where they cross. So if I had drawn in those lines, my first line looks like this. My second line looks like this. They both intersect at this point. So those two equations are equal at the point. Let's see, that's over 1, up 4. 1, 4 is my solution. If you plug those in, this would say 4 equals 4 times 1. That's true. This would say 4 equals 1 plus 3. That's true. So that is, in fact, my solution. I've got a few more that I want to show you. Okay, first one here. My slope is -2. So that means -2 over 1. It's negative, so it's telling me down and right. My y-intercept is at a -3. So my starting point goes at -3 on the y-axis. From there, I'm going to go down 2, right 1, down 2, right 1. There's no guarantee that it's going to cross down there. So I'm also going to continue in the opposite direction. Instead of going down 2, I'm going to go up 2. Instead of going right 2 or right 1, I'm going to go left 1. So from that first point here at -3, this time I'm going to go up to left 1, up to left 1. So everything still ends up being in line with each other. Okay, second equation. Y equals 2x plus 5. My slope is 2 or 2 over 1. That's positive, so it tells me up and right. And my y-intercept is at a 5. So starting here at 5, I would go up to right 1, but that's not really helpful because obviously they're not crossing up there. So again, I'm going to extend it in the opposite direction. Instead of going up 2, I'm going to go down 2. And instead of going right 1, I'm going to go left 1. So down 2, left 1, down 2, left 1. Hey, there's where they cross. Now, if you don't want to extend your points like that in the opposite direction, your other option is to get a straight edge. Get a ruler or fold and crease a sheet of paper and use that to help you keep your line straight. If you can draw it perfectly straight, then you'll see exactly where they cross. If your line is off even by a little bit, then your point, it may not cross where it exactly should. That's why I think it's so much more helpful if you just do a series of points like this. So this one, the solution would be at, let's see, the coordinates of that point are left 2, so it's -2, and then up 1, positive 1. I've got just a couple more. Okay, first one here, y equals -1/2 x plus 5. My slope is -1/2. It's negative, so it's telling me down and right. My y-intercept is at a positive 5. So my starting point goes at 5 on the y-axis. From there, I'm going to go down 1, right 2, down 1, right 2, down 1, right 2. Just in case it ends up crossing up there in the top left, I'm going to go up 1, left 2. You can always go back and extend it more and add more points if you discover that you need to as well. Okay, second one, my slope is 3, so that means 3 over 1. It's positive, so that's up and right. My y-intercept is at a -2. So down here, -2. From there, I'm going to go up 3, right 1. Up 3, right 1. There's my intersection point. The coordinates of that point would be +2, +4. There's your solution. That's the x and y combination that works in both equations at the same time. Last one. So that first equation, my slope is -2. That means -2 over 1. It's negative, so it's telling me down and right. My y-intercept, it doesn't show one, so that means it goes through the origin. So my starting point goes on 0, 0. From there, I'm going to go down to right 1, down to right 1, down to right 1. If I discover that it's going to cross in that second quadrant and I need it to be up there in the top left, do the total opposite. So up to left 1, up to left 1, up to left 1. Second equation, my slope is -2 over 1. That means down and right. My y-intercept is at a 5. So starting point at 5 on the y-axis, I'm going to go down to right 1, down to right 1, down to right 1. Well, what you should be noticing is that it's not looking too promising. I'm finding an intersection point. Sometimes they do cross at a point that's off your coordinate plane, and you need a bigger coordinate plane. However, I knew before starting that these two lines were never, ever going to cross. Anybody know how? If you look at your slope, both slopes were a -2. Your slope determines the slant of your line. So if both equations, both lines are slanted exactly the same, it makes them parallel, like train tracks. Parallel lines never cross. So if your two equations, if you already know that they have the same slope, you know there is no intersection point. That means that there is no solution. There's no x and y combination that's going to work in both equations at the same time. Parallel lines will never cross. So that's it on that lesson. Hopefully that helped. Thank you for watching and for sticking through to the end if you've made it this far. If you need more help with 7th or 8th grade math, feel free to subscribe. My channel is Math with Luger, and there's my school email if there's anything you need my help with. Thanks so much. Until next time. Bye.